We said in the last chapter that two particularly good kinds of thermometers were a constant volume thermometer, where we used the fact that pressure decreased as temperature decreased and increased as temperature increased in a gas, and a constant pressure thermometer, where we used the fact that at constant pressure, the volume increases with increasing temperature. So it turns out that if we use an absolute temperature, we can say that the pressure is proportional to temperature when we're at constant volume, and we can say the volume is proportional to temperature when we are at constant pressure. If instead we hold the temperature constant while varying the volume, we find that the pressure and the volume are inversely proportional to each other at constant temperature, or pressure times volume is a constant at constant temperature. Now, if I put all those things together, I find something very interesting. That says for a given sample, the pressure times the volume is proportional to the temperature. What's more is they did experiments and found that if you had more gas, you would have more pressure and volume for a given temperature. But the amount of gas depended on the specific gas. So if for example, 2 grams of hydrogen would behave very much like 4 grams of helium and like 32 grams of oxygen. And people wondered why that was. Avogadro suggested that maybe this was also proportional to the number of molecules there. So in other words, he said the pressure times the volume was proportional to the number of molecules in the gas times the temperature. And all we needed then was a proportionality coefficient. It turns out that we now know that proportionality constant is Kb, the Boltzmann constant, 1.38 times 10 to the negative 23 joules per Kelvin. Notice temperature would be measured in kelvins. Number of molecules is unitless, so kelvins would cancel. I'd be left with joules. Pressure times volume is a unit of work. Pressure is newtons per meter squared. Volume is meters cubed. Cubed cancels with the squared, leaving just a meter. I've got a newton meter. It's a joule. So putting this all together, I get a nice form, a nice equation that says pressure times volume equals the number of molecules times the Boltzmann constant times the temperature. And it's important that this temperature be measured in kelvins. If you do it in Celsius or Fahrenheit, it won't work out because 0 Celsius is not absolute zero. This is simply the ideal gas law, and you may have seen it before, although chances are you saw it in a slightly different form.